Hey guys, it's Mr. Zimmerman, and today we're going to talk about key characteristics of exponential graphs and do a bit of review before we end lesson 2. So let's dive in, shall we? So immediately I look at this function and I see that it's 1/5, which means it's going to be decaying. Now I know for the parent exponential, if I plug in an input of 0, I am always going to get an output of 1. Always, unless it's being transformed. So I know that there's going to be a y-intercept. I also know, because it's going to be decaying the whole time, it's going to be decaying from negative infinity to positive infinity. Now, I'm going to go ahead and sketch my graph, and it's decaying. And it's getting closer and closer to 0. Now, I know that it gets close to 0, but it doesn't touch it. So there's going to be a y asymptote, which keeps my range limited. So now my domain's a left to right scan, and I see that negative inputs work. Does 0 work? Absolutely. 0 gives me 1. And I test positive numbers, and it gets really small, but they all work. None of these break math. My range, though, if you were tempted to write the notation here, because you see, oh, none of them touch 0, you would be misled. It is not this form. It has to be parentheses 0 because of the asymptote. It actually does not touch the x-axis ever. This last part is end behavior, and you got to ask yourself what is happening as x approaches negative infinity to the left and as x approaches positive infinity. To help illustrate this, I'm going to use blue for negative infinity. If I go to the left, it gets really, really big. If I go to the right, it gets really, really small, and it gets so small that it's practically 0. Now, these last two is just review. Compounding daily, which means it's going to be 365 days a year. We're going to go ahead and write an equation. The amount of money is going to be equal to $1,000, and it's going to be, since it's interest, 1 plus 0.055. You go 1, 2, and then you fill in the gap with the 0. And since we're compounding daily, we're going to divide this guy by 365, and we're going to raise it to 365 times t. Now, we're going to go ahead and plug in 5, and we're going to just type this guy in, and we're going to get an amount of money. Now, similar thing. Bolivia had a population of 10.5 million and an annual growth rate of 1.6. So let's go ahead and talk about the population. The population in respect to time is going to be equal to 10.5 million. And we're going to go ahead and multiply it by 1 plus 0.12, 0.016. And we are going to go ahead and raise this to t. And voila, there's my formula. Now, I do got to be careful that 2010 is our reference point for this next problem. 2030 minus 2010 is going to go ahead and give me, hopefully you didn't have to use a calculator, it's going to be 20 years. So we got to figure out how many people are in Bolivia for 20 years into the future. Let's go ahead and input this. This is going to be 10.5 times 1.016 to the 20th power. And I just need to make sure you guys understand. So once you use the calculator, just know that whatever number it's going to give you, it's going to be million. And the reason being is because we shorthanded this. It's at 10.5 million. Instead of representing it as million, that would break our calculator quickly. We're just going to remember that we're not just dealing with people. We're dealing with not 1, 2, 3, 4, 5, and 100 and 200. If this is 200, it's going to be 200 million. I hope you guys enjoyed this. This ends lesson